Hello, welcome back to another show 2020 JEE Main, this time PYQs of limits. 2020 they conducted exam in the month of January and September instead of April. You know, the entire world was facing with COVID-19 now. So in the month of April it was a lockdown in India. So it is not conducted, JEE exam was not conducted in the month of April. January and September. I'll discuss all the questions of limits topic, okay, one by one. Various concepts are covered in 2020 as well as in April. Instead of April, they conducted the exam in the month of September. I think in January shift they ask only 2 questions on limits, and in September shift they ask 9 questions. The speciality of 2020 is they introduce the numerical type questions, okay. So 5 numerical type questions were introduced in 2020. So that's a main speciality. Not only multiple choice question, along with multiple choice questions, numerical type questions were there. Okay, we'll see one by one of limits topic. The first question: limit x tends to 0, 3x square plus 2 divided by 7x square plus 2 whole to the power 1 by x square is equal to how much? Question asked on 8th January 1st shift 2020. This takes which form? That is the most important thing always. Whether it takes 0 by 0 or infinity minus infinity or 1 to the power infinity, which indeterminate form it takes, that matters always. Then we apply the relevant method. Okay. So if you apply the limit directly or x equal to 0, what happens? 3 into 0, 0, 0 plus 2, 2. 7 into 0, 0, 0 plus 2, 2, numerator is 2, denominator is 2, 2 by 2 becomes 1, correct? And the power is becoming 1 by 0, correct? 0 square is 0, 1 by 0 is infinity. It takes 1 to the power infinity form. It takes 1 to the power infinity form, correct? This type of question was not asked in 2019, correct? I discussed the 13 questions which was asked in 2019, January and April shift. Okay, none of the questions were taking the form 1 to the power infinity. Of course, we had L'Hopital's rule, we had Newton-Leibniz formula, we had questions on rationalizing, some questions like L'Hopital's rule also we had, correct, trigonometric limits we had, but we didn't have 1 to the power infinity. None of the questions were asked. And left hand limit, right hand limit, and also limits involving the modulus function and greatest integer function, such kind of questions were asked. But none of the question was asked on 1 to the power infinity in 2019, remember. In 2020, the first question on, that is 8th January, 1st shift 2020, the question is asked on 1 to the power infinity. So do you know the formula? Already I discussed 1 to the power infinity formula in synopsis. So one of the most important formula, as I told you in the synopsis part. So as x tends to a, as x approaches a, f of x to the power g of x. F of x is approaching 1 and g of x is approaching infinity. Correct? In that case, limit x tends to a, f of x power g of x. What is the formula we have? Recall this. Limit x tends to a, f of x to the power g of x. Do you remember what is the formula I gave? Limit x tends to a, f of x power g of x is equal to what? E to the power limit x tends to a, g of x into f of x minus 1. This is the formula, right? This is the formula. As the base is approaching 1 and the power is approaching infinity, 1 to the power infinity form. The formula is this: as x approaches a, the base is approaching 1 and the power is approaching infinity. In that case, f of x power g of x as x approaches a is equal to what? I should write e to the power limit x tends to 0, correct? G of x, write the power first. This is base and this is power, correct? Write the power. Power is 1 by x square, 1 by x square into f of x minus 1. F of x is base. What is the base here? 3x square plus 2 divided by 7x square plus 2 minus 1. Correct? E to the power limit g of x into f of x minus 1. So this is equal to e power limit x tends to 0, 1 by x square into, take LCM here, inside this bracket, taking LCM, common denominator, 7x square plus 2, 1 is 1 by 1, 3x square plus 2 into 1, 3x square plus 2, 3x square plus 2 minus of 7x square plus 2, correct? Plus 2 minus 2 will cancel out, 3x square minus 7x square is minus 4x square, this is equal to e power limit x tends to 0, correct? 1 by x square into what we have 3x square minus 7x square minus 4x square divided by 7x square plus 2. X square cancels here, correct? What do you get? E power, I can apply the limit for this, minus 4 divided by x is approaching 0, put x equal to 0, 7 into 0, 0, 0 plus 2, 2, correct? So what we get is 4 by 2 is 2, so minus 4 by 2 minus 2, what we get is e power minus 2, which is 1 by e square. Answer is 1 by e square, takes 1 to the power infinity form. Learn the formula. As x approaches, say f of x power g of x, if it takes 1 to the power infinity form, the formula to be used is e power limit x tends to a g of x into f of x minus 1. Quite simple one. Question asked on 8th of January, first shift 2020 JEE exam. I am discussing the 2020 paper of limits. Okay. Hope you understand this. Also the solution is given to you, the detailed solution is given to you. If you want, you can take a screenshot of this, or else even I'll send the PDF in the Google Drive later. Okay, 1 to the power infinity form. Quite simple question asked. Move on to the next one. Integration sign is there, that means limit is there, integration sign is there. Most of the time you should apply L'Hopital's rule and Newton-Leibniz formula. Already we had 2 questions in 2019 as well, correct? X tends to a, correct? When x is approaching a, integration from 0 to 0. Integral from 0 to 0 is 0, correct? If lower limit and upper limit is same, integral value is going to be 0. And denominator is also 0. Takes 0 by 0 form. Takes 0 by 0 form. So we can apply L'Hopital's rule here, correct? Differentiate numerator and denominator separately. Apply L'Hopital's rule. What does L'Hopital's rule says? Differentiate the numerator and denominator separately. Correct? That is limit x tends to 0. Limit x tends to 0. Differentiate the numerator. D by dx of integral from 0 to x t sine of 10t dt. So for integration the variable is t here, correct, divided by d by dx of x. For numerator you are applying Newton-Leibniz formula. You are differentiating a definite interval, means apply Newton-Leibniz formula. Denominator derivative of x is 1. Numerator apply Newton-Leibniz formula. Integration and differentiation is going to cancel out. Substitute the upper limit, differentiate the upper limit, minus substitute the lower limit, differentiate the lower limit, correct? So what you get, this is equal to limit x tends to 0, limit x tends to 0, integration and differentiation is going to cancel out. What we get? X into sine of 10x, correct? In place of t, put the upper limit into derivative of upper limit. Derivative of x is 1. Minus substitute the lower limit 0 into sine of 10 into 0, 0, sine 0 into derivative of 0 is 0, correct? Divided by derivative of x is 1. Differentiate numerator and denominator separately. Numerator I am applying the Newton-Leibniz formula. Integration and differentiation are going to cancel out. Substitute the upper limit. In place of t, put the upper limit into derivative of upper limit. Minus substitute the lower limit. In place of t, put the lower limit into derivative of 0, 0. Now apply limit for this. What we get? This is equal to, what you get? X equal to 0, no? 0 into sine of 10 into 0, 0. So sine 0. 0 into sine 0, which is equal to 0. Sine 0 itself is 0. 0 into 0 is 0. Answer is 0. Option A is answer. applying L'Hopital's rule and Newton-Leibniz formula. Hope you understand. For the third time using this Newton-Leibniz formula. In 2019 paper also we applied 2 times, I remember. This is the third time we applied Newton-Leibniz formula. Okay. The solution is also given to you. Please make a note of this. Move on to the next one. As I told, only 2 questions were asked in April shift 2020. Next questions are from September shift. Okay. The question asked on 2nd September, 2nd shift 2020. Limit extends to 0. Tan of pi by 4 plus x power 1 by x. As x approaches 0, put x equal to 0. Pi by 4 plus 0 is pi by 4. Tan pi by 4 is 1. 1 by 0 is infinity. Correct? Takes 1 to the power infinity form. Same question I discussed earlier in synopsis also. Do you remember those who watched my synopsis of limits? Same question I taken for as an example in 1 to the power infinity form. This takes 1 to the power infinity form. What is the formula? F of x power g of x is as x approaches c. If it takes 1 to the power infinity form, what is the formula? E power limit g of x into f of x minus 1. So what should I write now? Is equal to e power limit x tends to 0, e power limit x tends to 0, g of x. G of x means write the power first. Write the power multiplied by the base. What is the base? Tan of pi by 4 plus x minus 1. Tan of pi by 4 plus x minus 1. This is equal to e power limit x tends to 0. What we get? 1 by x into, what is the formula for tan of pi by 4 plus x? Trigonometric formula we had, compound angle. 1 plus tan x by 1 minus tan x, right? Tan of pi by 4 plus x is 1 plus tan x divided by 1 minus tan x. Simplified further is equal to e power limit x tends to 0, 1 by x into, taking common denominator, 1 minus tan x. Here take LCM, 1 plus tan x into 1 is 1 plus tan x minus of 1 minus tan x is equal to e power limit x tends to 0, 1 by x into 1 minus 1 0, tan x minus of minus tan x, tan x plus tan x, 2 tan x, correct, divided by 1 minus tan x. Simplified further, I'll write the remaining part here is equal to e power limit x tends to 0. I can write this as 2 times tan x by x, 2 into tan x divided by x, correct, group like this, into tan x by x I wrote, into 1 by 1 minus tan x, like this, is equal to e power 2 into, and now I am applying the limit. As x tends to 0, we know the familiar result, tan x by x is 1 as x tends to 0. And here also I can apply the limit for this. Limit of f into g is limit of f into limit of g. So 1 by 1 minus tan 0 is 0. So I am getting e power 2 into 1, 2. E square is the answer. Answer is e square, option C. Simple question asked, okay, on limits. Hope you understand this. Learn all the formulas. Tan of pi by 4 plus x, 1 plus tan x by 1 minus tan x. Learn the formula properly and learn the limiting formula also. As x tends to 0, I am applying 1 to the power infinity form. The solution is also given to you. Okay. Next one, question number 4. Box of t denotes the greatest integer less than or equal to t for some lambda belongs to set of real numbers except 0 and 1. Okay, limit x tends to 0, mod of this is equal to L, then L is equal to how much? Because there is modulus function, also there is greatest integer function. The first task is to find out the left hand limit and right hand limit separately. Okay, already limit of the function is going to exist, the given it, you have to find the value of L. So I'll find out the left hand limit and right hand limit separately and evaluate it. Okay, so first we'll find out the left hand limit now. Because the given expression involves the modulus function and greatest integer function, I make use of finding left hand limit and right hand limit separately. So left hand limit is limit x tends to 0 minus, limit x tends to 0 minus mod of 1 minus x plus mod x divided by lambda minus x plus greatest integer value of x. That is given to be equal to L. I'll use that later. For time being, just I'm using the left hand limit. As I told earlier, x tends to 0 minus means put x equal to 0 minus h, where h is a small positive quantity. Put x equal to 0 minus h. Put x equal to 0 minus h, where h tends to 0, a small positive quantity. Limit h tends to 0 mod of 1 minus, wherever there is x you put minus h. 0 minus h is minus h, correct? 0 minus means slightly less than 0. 0 minus a small positive quantity. So 0 minus h. Wherever there is x you put minus h. Okay? Minus h plus mod of minus h divided by lambda minus, put x is minus h plus greatest integer value of minus h, correct? As I explained earlier, mod of minus h is same as mod h, and mod h is h because h is positive, and integral value of minus h is minus 1 as h tends to 0. H tends to 0 means to take h equal to 0.1. Integral value of minus 0.1 is minus 1. I can apply the limit inside this modulus function, okay? So this is equal to, what I'm getting is limit h tends to 0, I'll keep as it is. I'll apply the modulus function. I'll simplify for the greatest integer function here. Mod of 1 minus of minus h is plus h, and mod of minus h is same as mod h. Mod h is h because h is positive, divided by lambda plus h, and integral value of minus h will be minus 1, correct? Now we can apply the limit inside the mod, correct? Because how to apply limit for a composite function we know. Limit of mod is mod of the limit. Apply limit h equal to 0 inside this. What do you get? H is becoming 0. H is becoming 0. 0 plus 0 is 0. 1 plus 0 plus 0, correct? 1 divided by mod of lambda plus 0 minus 1. So I'm getting 1 by mod of lambda minus 1. Applying limit h equal to 0, 0, 0, correct? Numerator is 1 plus 0 plus 0, that is 1. Mod of 1 is 1. Denominator is mod of lambda plus 0 minus 1, that is mod of lambda minus 1. This is left hand limit. Now go to the right hand limit. Right hand limit is what? Limit x tends to 0 plus. Right hand limit is limit x tends to 0 plus of the same expression. X tends to 0 plus, what is given? Mod of 1 minus x plus mod x divided by lambda minus x plus greatest integer value of x. Now 0 plus means what? Slightly greater than 0. So put x equal to 0 plus h, where h is a small positive quantity. Put x equal to 0 plus h. Put x equal to 0 plus h, where h is tending to 0, a small positive quantity. Okay? In that case, what we get? Limit h tends to 0, correct? Mod of 1 minus, wherever there is x you put h. Mod of h, correct? Divided by lambda minus, in place of x you put h. In place of x you put h. Correct? Now, mod of h is h. Integral value of h is 0. As h tends to 0, here it was minus h. Now it is integral value of h. H is 0.1. Integral value of 0.1 is going to be 0. Correct? This is becoming 0. So what do you get? Apply limit for this. What do you get? Limit h tends to 0. Limit h tends to 0. Mod of 1 minus h. Mod of h is h because h is positive, divided by lambda minus h plus 0. Minus h plus h will add up to 0. 1 plus 0 is 1. Mod 1 is 1, divided by denominator, apply h equal to 0. Lambda minus 0 is lambda. So 1 by mod of lambda. Applying the limit, we get like this. So left hand limit we got 1 by mod of lambda minus 1. Right hand limit we got 1 by mod of lambda. Because limiting value of this is given to b equal to L. That means limit of the function is going to exist finitely. Limit exists means left hand limit should be equal to right hand limit. So equating these two, I'll get the value of lambda. Correct? So limit exists implies, I can add one more slide here. Left hand limit equal to right hand limit. Correct? Limit exists. Limit of the function is going to exist. Limit exists implies left hand limit is equal to right hand limit. Left hand limit is 1 by mod of lambda minus 1, right? Left hand limit you got 1 by mod of lambda minus 1. 1 by mod of lambda minus 1. Right hand limit we got 1 by mod of lambda. Taking reciprocal we get mod of lambda minus 1 is equal to mod lambda. That means lambda minus 1 is equal to lambda, or lambda minus 1 is equal to minus lambda. The two possibilities here. If you remove the modulus sign, correct? This gives lambda cancels on either side. Minus 1 equal to 0, which is not possible. Minus 1 equal to 0 is not possible. Cancelling lambda on both sides. Here lambda plus lambda, 2 lambda is equal to 1, or you get lambda is equal to 1 by 2. So answer is lambda equal to 1 by 2. That is a solution. 0 equal to minus 1 we get here. That's not possible. And here equating this lambda equal to half. That's the answer. Okay. Option C is the answer. Next move on to the question number 5. Limit x tends to A is given like this. Question asked on 3rd September, 2nd shift 2020. Simple question here. A is not equal to 0. If you apply limit directly or x equal to A, it becomes A plus 2A, 3A. 3A power 1 by 3. Here also 3A power 1 by 3. So numerator becomes 0. Denominator is what? 3A plus A, 4A. 4A power 1 by 3 minus 4A power 1 by 3. Takes 0 by 0 form. Correct? Can apply L'Hopital's rule. If you apply the limit directly, it takes 0 by 0 form. Takes 0 by 0 form. Differentiate numerator and denominator separately. Apply L'Hopital's rule. It's suitable here. Apply L'Hopital's rule. Differentiate the numerator and denominator separately. L'Hopital's rule says that we should differentiate the numerator and denominator separately. So then apply the limit until that 0 by 0 form is removed. Differentiate a plus 2x power 1 by 3. Derivative of x power n formula, or derivative of x power n into x power n minus 1. I am applying the chain rule there. Correct? 1 by 3 into a plus 2x to the power 1 by 3 minus 1, which is minus 2 by 3 into derivative of a plus 2x, that is 2, minus 1 by 3 into 3x to the power 1 by 3 minus 1 minus 2 by 3 into derivative of 3x is 3. Denominator differentiate 1 by 3 into what do you get? 3a plus x to the power 1 by 3 minus 1, that is minus 2 by 3 into derivative of 3a plus x. 3a is constant, derivative constant is 0. Derivative of 3a is 0, derivative of x 1, 0 plus 1 is 1, into 1 I can write, minus derivative of 4x power 1 by 3 is 1 by 3 into 4x to the power 1 by 3 minus 1, which is minus 2 by 3 into derivative of 4x is 4. Now we can apply the limit here. Wherever there is x you put a. In place of x just put a, because x is approaching a. So this becomes a plus 2a, 3a. So 1 by 3 I can cancel it, correct? In the numerator 1 by 3 is common. In the denominator also 1 by 3 is common. So cancel it out. 1 by 3 I will not write next step. So a plus 2a becomes 3a. So 2 times 3a to the power minus 2 by 3. 1 by 3 I won't write. This is minus 3 into putting x equal to a. This becomes 3a to the power minus 2 by 3. Denominator 1 by 3 is cancelled out from numerator and denominator. Again I won't write 1 by 3. 3a plus a becomes 4a to the power minus 2 by 3 minus. Here this 1 by 3 is cancelled out. What is left is 4 into 4a to the power minus 2 by 3. Correct? 3a power minus 2 by 3 is common, correct? So these are like terms we can add, like 2 minus 3 is minus 1. So this becomes minus of 3a to the power minus 2 by 3. Denominator, like terms, no, 4a power minus 2 by 3 is common. 1 minus 4 is minus 3. So it is minus 3 times 4a to the power minus 2 by 3. Correct? Minus minus will cancel. So I'll write the remaining part here. That's equal to 1 by 3 into, and a power minus 2 by 3 is cancelled out, correct? A power minus 2 by 3 cancels. What is left is 3 power minus 2 by 3. 3 power minus 2 by 3 divided by 4 power minus 2 by 3. Correct? I can write this as 1 by 3 into 4 power minus 2 by 3. Take it to numerator. It becomes 4 power 2 by 3. 4 is of course 2 square. No, I can write this as 2 square power 2 by 3. And 3 power minus 2 by 3. Take it to denominator. It becomes 3 power 2 by 3. So what we get? 1 by 3. 2 square is 4. 4 power 2 by 3. Correct? Or I can multiply as 4 power 2 by 3. 4 power 2 by 3. Or I can write 2 power 4 by 3. That is also same, no? 2 square is 4. Powers gets multiplied. 2 power 4 by 3. And I can write this as 3 square power 1 by 3. 3 square is 9. 9 power 1 by 3. Which is equal to 1 by 3 into, this is 2 power 1 into 2 power 1 by 3. Because 1 plus 1 by 3 is 4 by 3. Right? Divided by 9 power 1 by 3. So answer is 2 into 1 by 3. 2 by 3 into 2 by 9 whole power 1 by 3. That's the answer. 2 by 3 into 2 by 9 power 1 by 3. Option B is the answer. Hope I understand this simplification. Okay. 4 power minus 2 by 3 is taken up to numerator. Becomes 4 power 2 by 3. 3 power minus 2 by 3 numerator brought to denominator becomes 3 power 2 by 3. 3 square power 1 by 3. 3 square is 9. So 9 power 1 by 3. And this is 2 square is 4. I didn't write 4 power 2 by 3. I wrote 2 power 4 by 3. I multiplied the powers there. So 4 by 3 is 1 plus 1 by 3. Split that. 4 by 3 is written as 2 power 4 by 3 is 2 power 1 into 2 power 1 by 3. Because 1 plus 1 by 3 is 4 by 3. So this is answer. Option B is answer. 2 by 3 into 2 by 9 power 1 by 3. Hope I understand this. Applying L'Hopital rule and little bit of simplification is involved here. Okay. Please make a note of this. Understand it properly. Okay. Not a difficult question. Little bit of simplification is there. That you do it properly. Solution is given. Answer is option B. Detailed solution is given to you. Applying L'Hopital rule and getting the answer. Next one. Alpha is a positive root of this equation. A polynomial is given here. Find the roots of this. And alpha is a positive root of this. Then you have to use this alpha here. Limit x tends to alpha plus right hand limit at x equal to alpha. Root of 1 minus cos of p of x by x plus alpha minus 4 is equal to how much? Question asked on 5th of September, first shift 2020. You know 5th of September is Teachers Day, right? Question asked on Teachers Day. So first solve this equation p of x. P of x is given as x square minus x minus 2 equal to 0. Solving this equation, solving this quadratic, adding we should get minus 1, multiplying we should get minus 2. I can take the factors as x minus 2 into x plus 1 equal to 0. Correct? X minus 2 into x plus 1 equal to 0, which gives x is equal to 2 or x equal to minus 1. I'll take x equal to 2 because it told alpha is a positive root. Since alpha is a positive root of this polynomial of degree 2, I'll take alpha equal to 2. Take alpha equal to 2 because they told alpha is positive. Take alpha is equal to 2 because they told alpha is a positive root of this equation. So x tends to alpha plus alpha is 2. So I can substitute alpha equal to, therefore given limit becomes limit x tends to 2 plus, putting alpha as 2. 2 plus, what is the root of 1 minus cos of p of x. P of x is polynomial, no, x square minus x minus 2. I'll factorize and write it, okay? That's easier. X square minus x minus 2. How to factorize? X minus 2 into x plus 1. X minus 2 into x plus 1. That is how you factorize it. Correct? Divided by putting alpha as 2. X plus 2 minus 4. So what we get? This is equal to root of, that is limit x tends to 2 plus, what I'll do is I'll take this denominator inside the root. So it becomes whole square, right? If 2 minus 4 is minus 2, denominator is actually x minus 2. X minus 2 is taken inside the root, means it becomes x minus 2 the whole square, correct? So this becomes root of 1 minus cos of x minus 2 into x plus 1, that is an angle there, correct? Divided by denominator is x minus 2, that is taken inside the root, means it becomes x minus 2 the whole square, correct? Now I am using this familiar result, limit theta tends to 0. This is one of the familiar result already given in the synopsis too. 1 minus cos theta by theta square is equal to half. Limit theta tends to 0, 1 minus cos theta by theta square is half. Such an important result. It's quite useful. In many of the problems, this result is useful. I'm using this result. Okay. So here theta is what? Instead of theta, if we compare, theta is x minus 2 into x plus 1, right? And the same thing square. Whatever there in theta, no, square of that should be present in the denominator. So here the angle is x minus 2 to x plus 1, right? So inside the root I'll multiply and divide by x plus 1 the whole square. Okay, multiply and divide by x plus 1 the whole square. And for this I'm applying the limit. You can take the limit inside the square root. You know, limit x tends to a of square root of f of x is, we can take the limit inside the root. This takes 1 minus cos theta divided by theta square. Whatever angle is there, no, square of that angle should be present in the denominator. We take this form 1 minus cos theta by theta square, as theta tends to 0, limiting value is half. See, x tends to 2 plus means this angle is becoming 0 because 2 minus 2 is 0. So this part will become half, correct? This entire thing will become half inside the root. And for this I can apply limit directly on x tends to 2, no, 2 plus 1, 3, 3 square, 9, correct? This becomes root of whatever is rounded off is taking the form 1 minus cos theta by theta square, which is 1 by 2 into, for this you apply limit directly, x equal to 2, no harm in applying the limit, put x equal to 2 here, 2 plus 1, 3, 3 square is 9, correct? So root 9 is 3, 3 by root 2 is the answer, 3 by root 2 is the answer, option D. Hope you understand. This x plus 2 minus 4 is nothing but x minus 2, because 2 minus 4 is minus 2. X minus 2 is taken inside the root, it becomes x minus 2 the whole square. Okay, and I multiply and divide by x plus 1 the whole square within the square root, because I want to take this form 1 minus cos theta by theta square is half, as theta tends to 0. 1 minus cos of an angle by that angle square. So x minus 2 the whole square was already present. I multiply and divide by x plus 1 the whole square, and whatever there inside rounded off, no, that is half. And for this I am applying limit directly, x equal to 2 plus 1, 3, 3 square is 9, root of 9 into half, root 9 is 3, and root of 1 by 2, that is divided by root 2, 3 by root 2 is the answer. Hope you understand this. Solution is also shown to you here, detailed solution is given to you. Okay, please make a note of this. Move on to the next one, question number 7, limit x tends to 0, x into e power root of 1 plus x square plus x power 4 minus 1 by x minus 1 divided by root of 1 plus x square plus x power 4 minus 1 equal to how much? Question asked on 5th of September, second shift, 2020. So this we can rewrite it as limit x tends to 0, limit x tends to 0, exponential function is involved here, right? Is equal to e power root of 1 plus x square plus x power 4, correct, minus 1 divided by x, correct, minus 1 divided by root of 1 plus x square plus x power 4 minus 1 divided by x. This x is the numerator, it is taken to denominator's denominator, so that this is same, correct? This part is same. The power of e and the denominator is same, these two are same, correct? We know the limit theorem, that limit h tends to 0, we know this familiar result on exponential function, limit h tends to 0, e power h minus 1 by h is equal to 1, right? Limit h tends to 0, e power h minus 1 by h is 1. The h is tending to 0. The power and denominator should be same. and both are tending to 0. It is of this type. See, this power is same as the denominator. Whether it is tending to 0, you have to find out. If that number, that expression, that bracket is tending to 0, then answer is 1, because it takes this form. E power h minus 1 by h is 1 as h tends to 0. Correct? So this power, the exponential e power, what is there, that is same as the denominator, because this x is written as 1 by x. X is taken to denominator's denominator. Hope you understand this. Okay. Now I'll take this quantity separately and evaluate it. If this expression, if you take separately, okay, suppose limit x tends to 0, you can apply limit for that, power root of 1 plus x square plus x power 4, correct, minus 1 divided by x. If you apply the limit directly for this, it takes 0 by 0 form, right? Denominator is becoming 0, x equal to 0. X equal to 0, 0 square, 0 power 4, 0 plus 1, 1. Root 1 is 1, 1 minus 1, 0. 0 by 0 form it takes. 0 by 0 form. So I can apply L'Hopital's rule for this, correct? Differentiate numerator and denominator separately. Applying L'Hopital's rule. Derivative of root x is 1 by 2 root x. 1 by 2 root of 1 plus x square plus x power 4 into derivative of 1 is 0. Derivative of x square 2x. Derivative of x power 4, 4x cube. Derivative of 1, 0 divided by derivative of x is 1. Now apply limit for this. X equal to 0. What do you get? 2 into 0, 0. 4 into 0, 0. Numerator is 0 here. Denominator is 2 into root of, correct, 1 plus 0 plus 0. Putting x equal to 0. Correct? We get like this. 0 by 2. 0 by 2 is equal to 0. Correct? So limit of this is becoming 0. Limit of this becoming 0. So limit of this is becoming 0. That is, the power and denominator both are same and both are approaching 0 as x tends to 0. This is exactly in this form. E power h minus 1 by h is 1 as h tends to 0. This power is approaching 0 and this power is same as the denominator. So this and this both same and approaching 0, means exactly in this form. So e power h minus 1 by h as h tends to 0, that is equal to 1. So required answer is 1. Quite simple. In 2 steps you get the answer. Not a big deal. Okay. So question answer on 5th of September 2020, second shift. 7th question. This is answer is 1. And the solution is also given to you here. Detailed solution is given to you. Answer is 1. Hope you understand. Move on to the next one. Question number 8. Integration sign is there. Limit is there. That means it's a combo of L'Hopital's rule and Newton-Leibniz formula. If you apply x equal to 1 limit directly, denominator is becoming 0. 1 minus 1, 0. 0 into sine 0, 0. And here when you put x equal to 1, 1 minus 1, 0. Upper limit of the integration is becoming 0. Lower limit is already 0. Integral from 0 to 0 is 0, right? So this takes 0 by 0 form. 0 by 0 form. That means you need to apply L'Hopital's rule and differentiate the numerator, apply Newton-Leibniz formula. Correct? 0 by 0 form. So apply L'Hopital's rule. Differentiate the numerator and denominator separately. I'll write LH rule in short. Okay. So if you apply the limit here, limit x tends to 1. Limit x tends to 1. Differentiate the numerator. d by dx of integral from 0 to x minus 1 the whole square into t into cos of t square dt. Correct? For integration the variable is t and the variable for the integration is, after integrating, it's a function of x. Denominator also differentiate x minus 1 into sine of x minus 1. Numerator, when you differentiate the definite integral, what happens? Integration and differentiation is going to cancel out. Substitute the upper limit into differentiate the upper limit, minus substitute the lower limit, differentiate the lower limit. Correct? And denominator, I need to apply the product rule there, because it is multiplication of two functions. Product of two functions, apply the product rule. Here it's product of two functions, right? So apply the product rule. What do you get? Limit x tends to 1. Limit x tends to 1. What do you get? Differentiate the definite integral. Substitute the upper limit. What do you get? X minus 1 the whole square into cos of x minus 1 the whole square becomes x minus 1 power 4. Correct? Into derivative of x minus 1 the whole square. That is 2 times x minus 1 into derivative of x minus 1 is 1. Lower limit is 0. 0 and anything is 0. 0 and any finite number is 0. And derivative of 0 is also 0. and denominator you need to apply product rule. First function keep as it is, differentiate the second function. Derivative of sine of x minus 1 is cos of x minus 1 into derivative of x minus 1 is 1 plus sine of x minus 1 second function into derivative of the first function, derivative of x minus 1 is 1. Now you can see x minus 1 is common in the numerator, correct? In the denominator one term contains x minus 1, so I'll divide numerator and denominator by x minus 1. If you divide the numerator and denominator by x minus 1, what I'm going to get is limit x tends to 1, correct? I'm dividing the numerator by x minus 1, so this x minus 1 I won't write, so what I'll write is 2 into x minus 1 the whole square into cos of x minus 1 to the power 4 divided by denominator also divide by x minus 1, so I get cos of x minus 1 plus sine of x minus 1 divided by x minus 1, correct? As x tends to 1, x minus 1 will approach 0, right? As x tends to 1, x minus 1 tends to 0. Sine of an angle by same angle, this becomes 1. This entire thing will become 1, correct? Tends to 1. And x tends to 1, here 1 minus 1, 0. Cos 0 is 1. Correct? Numerator also becomes 0 here, correct? 2 into 1 minus 1, 0. Put x equal to 1. 1 minus 1, 0. 0 into 2 becomes 0. Numerator is 2 into 0 divided by denominator is 1 plus sine theta by theta is 1 as theta tends to 0. 2 into 0, 0. 0 by 2 which is equal to 0. Answer is 0. E is equal to 0. Option B is answer. Quite simple question. Combo of L'Hopital's rule and Newton-Leibniz formula. Hope you understand this. Move on to the next one. The solution is also given to you here for ready reference. You can look at the solution here if you want to take a screenshot of this, and move on to the next one. Ninth question onwards, the numerical type question. There is no options given to you. Numerical type, most of the time they give numerical type, that is the integer type question, integer values. Okay, even in JEE advanced exam these type of questions are familiar. It's introduced in the JEE Mains exam for the first time in the year 2020 onwards. So limit x tends to 1, the limit of this expression is given to be equal to 820. N is a natural number, find the value of n. Question asked on 2nd of September, first shift 2020. So as x is approaching 1, denominator is becoming 0, right? 1 minus 1, 0. Numerator, apply limit directly, what happens? 1 plus 1 square plus 1 cube, etc. 1 power n. How many terms are there here? N terms are there, correct? All becomes 1, 1, 1. Adding 1 n times becomes n minus n, 0. It takes 0 by 0 form, correct? 0 by 0 form is you can apply L'Hopital's rule, a familiar result. Applying L'Hopital's rule, differentiate the numerator and denominator separately. Apply L'Hopital's rule. Apply L'Hopital's rule, differentiate the numerator and denominator separately. What we get? Limit x tends to 1, differentiate the numerator, derivative of x1, derivative of x square, 2x, derivative of x cube, 3x square. Likewise, we go on, continue, derivative of x power n into x power n minus 1, derivative of n is 0, n is a constant, denominator differentiate, derivative of x1, derivative of 1, 0 is given to be equal to 820. Now we can apply the limit x equal to 1, 1 plus 2 into 1, 2, 3 into 1 square, 3, etc. Continue this, n into 1 to the power n minus 1, 1 into n, denominator is 1, no need to write. This is equal to 820, it's given to us. This is sum of the first n natural numbers. We know sum of the first n natural numbers is summation of n. Summation of n is what? N into n plus 1 divided by 2. N into n plus 1 divided by 2 is equal to 820. Cross multiply this and simplify. N into n, open the bracket, n square plus n is equal to 820 into 2 becomes 1640. Or you can write this as n square plus n minus 1640 equal to 0. You can factorize it. Adding you should get 1 and multiplying you should get minus 1640. That is n plus 41 into n minus 40. Because 41 minus 40 is 1. 41 into minus 40 is minus 1640. This gives n equal to minus 41 or n is equal to 40. N equal to minus 41 is not possible because it's not a natural number. N equal to 40 is the answer. 40 is a natural number. So required value of n is 40. Very simple question. Just differentiate the numerator and denominator separately. Apply the limit and then use the summation of n formula. Sum of the first n natural numbers is n into n plus 1 divided by 2. Cross multiply, solve the quadratic equation, get the value of n as a natural number. Required answer is n equal to 40. Solution is also given to you. Answer is 40. Move on to the next one. Limit x tends to 0, 1 by x power 8 into 1 minus cos of x square by 2 minus cos of x square by 4 plus cos of x square by 2 into cos of x square by 4 equal to 2 power minus k. Find the value of k. Question asked on 3rd of September, first shift 2020, numerical type question. So trigonometric function you can see cos. I can simplify it like this. In the first two terms you keep as it is inside the bracket. In the third and fourth term you can see that minus cos of x square by 4 is common, right? So I can simplify it like this. Limit x tends to 0. Limit x tends to 0. 1 by x power 8. 1 by x to the power 8 into, correct, 1 minus cos of x square by 2. This you write it in one bracket, minus third and fourth term I can take minus cos of x square by 4 common. So what remains? 1 minus cos of x square by 2. Correct? This much is left out. Close this bracket. Close the bracket. Is given to be equal to 2 power minus k. Now I can write this into 1, right? Into 1 I'll write. No harm in writing that. So that you can see 1 minus cos of x square by 2 is common. So this is equal to limit x tends to 0. Limit x tends to 0. This is equal to limit x tends to 0. 1 by x power 8 into 1 minus cos of x square by 2 is common. It's multiplied by. So what remains is 1 minus cos of x square by 4. I'm simplifying this using the trigonometric limits. So I'm using the half angle formula here. 1 minus cos theta. What is half angle formula? 1 minus cos theta is 2 sine square theta by 2, right? You must know this half angle formula right here. 1 minus cos theta is equal to 2 sine square theta by 2. So half angle formula, submultiple angle formula. For both the brackets, I'm using this formula. 1 minus cos theta, learn it. 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta, my theta is x square by 2 here for the first bracket. For the second bracket, theta is x square by 4. So what can I write from this? Limit x tends to 0. Limit x tends to 0. Open a bracket, 1 by x power 8, that you keep as it is. This is 2 sine square theta by 2. X square by 2 half will be x square by 4. Correct? The first bracket is like this. And the second bracket is 2 sine square x square divided by 8. Like this. Is equal to 2 power minus k. Correct? 1 minus cos theta, 2 sine square theta by 8. 1 minus cos theta, 2 sine square theta by 8. 2 into 2 is 4. So what do you get? Limit x tends to 0. 2 into 2 is 4, right? I can simplify sine theta by theta is equal to 1. Theta tends to 0 using that result. Okay? Or else I can directly write the answer. If you note the synopsis, I already explained the synopsis, this type of result. See, sine square, no? Here also sine square. And here x square will be x power 4. Here also x square is x power 4. X power 4 into x power 4 will be x power 8. Denominator is also x power 8. Correct? Just we can write the coefficients and get the answer. Otherwise I'll do the steps if you want. See, 2 into 2 is 4. Correct? 4 I wrote. Sine square x square by 4 is there. No, that means what? Sine x square by 4 into sine x square by 4. Correct? Sine of x square by 4 into sine of x square by 4. That's the meaning. Sine square theta means sine theta into sine theta. Correct? Sine square x square by 8 means what? Sine of x square by 8 into sine of x square by 8. Correct? Sine square theta means sine theta into sine theta. Correct? Now what you do is x power 8 is there already. For that I'll write x square into x square into x square into x square. So that x power 8 I wrote. X square into x square into x square into x square is x power 8. Correct? You divide by 4. You divide by 4. You divide by 8. Divide by 8. To balance it, multiply by 4 square into 8 square. Correct? Hope you understand this. Is given to be equal to 2 power minus k. Sine of an angle by same angle is 1. Sine of an angle by same angle is 1. Sine x square by 4 by x square by 4 is 1. Sine x square by 8 by x square by 8 is 1. Sine x square by 8 by x square by 8 is 1. Correct? So what is left? See, 1 4 is going to cancel. 1 4 remains there. Correct? I'll write the answer here, remaining part. That's equal to, what is left? 4. Here 4 square, so 1 4 cancel, so 1 by 4 into 1 by 8 square, 8 square is 64, 64 into 4 is 256, correct? 1 by 256, 256 is 2 power 8, so is equal to 2 power minus 8 is equal to 2 power minus k, is already given to us. If we compare, the value of k is equal to 8. Hope you understand this. The value of k is equal to 8. Is that clear? Solution is given to you. The value of k is 8. Detailed solution is given to you. And move on to the next one. The last question, I think, of this 2020. After this session, in the next session, I'll be doing 2021 PYQs of limits chapter. Then 2022, 23 like that. One by one, we'll be covering all the topics. Okay. Limit x tends to 2. If you apply limit directly, what happens? You see, 3 square plus 3 power 3 minus 2 is 1 minus 12 divided by 3 power, put x equal to 2 minus 2 by 2, that is minus 1, correct, minus 1 minus 3 power 1 minus 2 minus 1. 3 square is 9, 9 plus 3 12, 12 minus 12 0, 3 power minus 1 minus 3 power minus 1 0, 0 by 0 form. So apply L'Hopital's rule. Here it is derivative of a power x formula, derivative of 3 power x. L'Hopital's rule says you differentiate the numerator and denominator separately. I am using the formula for derivative of a power x. What derivative of a power x? Derivative of a power x is a power x into log a, right? Derivative of a power x, d by dx of a power x. D by dx of a power x is equal to what? A power x into log a base e, correct? So derivative of 3 power x will be 3 power x log 3. Applying L'Hopital's rule. Apply L'Hopital's rule. Differentiate the numerator and denominator separately. Apply L'Hopital's rule. Differentiate numerator and denominator separately. What we get? Limit x tends to 2. Limit x tends to 2. Derivative of 3 power x is 3 power x into log 3. Derivative of 3 power 3 minus x. 3 power 3 minus x into log 3 into derivative of 3 minus x is minus 1. And derivative of 12 is 0. 12 is a constant. Differentiate the denominator as well as derivative of 3 power minus x by 2 is 3 power minus x by 2 log 3 into derivative of minus x by 2 minus half minus derivative of 3 power 1 minus x. 3 power 1 minus x log 3 into derivative of 1 minus x minus 1. Log 3 is common in the numerator and denominator. Take out common and cancel out. Log 3, log 3, log 3 cancels out. Simultaneously apply the limit x equal to 2. What we get? 3 square plus into minus is minus. 3 power 3 minus 2, that is 1. Correct? Log 3 is cancelled. Plus into minus is minus. And denominator minus half into 3 power minus 2 by 2, that is minus 1. Here minus into minus will be plus. What is left? 3 power 1 minus 2. 3 power 1 minus 2 is minus 1. Correct? So 3 square is 9. 9 minus 3 divided by 3 power minus 1 is 1 by 3. Correct? This 1 by 3 into minus half, that is minus 1 by 6 plus 1 by 3, because 3 power minus 1 is 1 by 3. 9 minus 3 is 6. Take LCM 6. 6 into 1, 1 into minus 1, minus 1, 3 into 2, 2 into 1, this 6 will go up, 6 into 6, 36, divided by 2 minus 1, 1, answer is 36. Simple question. Hope you understood all the questions of 2020 JEE Main, okay, appeared in January shift and September shift. Totally we had 11 questions, and if you want, the solution is also given to you. Answer is 36. A detailed solution is given to you. Applying L'Hopital's rule, 1 to the power infinity, also the questions were asked in this 2020 paper. 2 of the questions are asked on 1 to the power infinity and also Newton-Leibniz formula. So far the questions are not asked on series expansion 2019 and 20. No questions were asked on series expansions, that is Maclaurin series expansions, there are some particular infinite series expansions based on that, e power x, e power minus x, all those things, log 1 plus x, log 1 minus x, finding the unknowns using the series expansion. Okay, such kind of questions are not asked so far, can be asked and already is asked in many of the other papers. We'll be discussing more of limits in the coming days, and please subscribe to my channel, please inform your friends. It's also useful for the teachers, also beneficial for teachers also, because many times even the experienced teachers also need some of the important tricks to be taught for the students, so you can grab from this session. It's quite useful because I'm an experienced teacher actually. From the many years I'm teaching mathematics exclusively for PU students. I may be a new YouTuber, but I'm not a new teacher for PU students, and many students like my teaching too. So my name is Abhiram. Those who do not know, it's Abhiram's Maths Marathon classes started. I'm a new YouTuber. I'll be uploading many more videos in the coming days for all competitive exams. I'll be covering all the PYQs. It may be JEE Mains or JEE Advanced, NDA, then also VIT, EEE, MAE exams, Comet K, KCET, and various other competitive exams I'll be doing. Even IISER also I'll be doing, but I need time. BitSet also we can do. All PYQs will be covered in my YouTube channel. And please subscribe to my channel, watch my videos, inform to your friends, or even for teachers also it's beneficial. Okay, please do watch my channel. Okay, classes, all those things. Even the NCERT syllabus also I'll be doing, NCERT exam, the 2 NCERT concepts also, along with the solutions of NCERT exercise. All the things will be discussed one by one. With this we'll conclude. Okay, thank you.